How's it going? Mike coming back at you here with another video on Calculus 1. In the previous video, we talked about taking the compositions of functions and being able to identify what are the two functions making up your composition, and then we got into the statement of the chain rule, which says that if you take the composition of two functions, f of x as well as g of x, and you compose those to get f circle g of x or f of g of x, as you see below, then the derivative of f of g of x is f prime of g of x times g prime of x. We're going to take that inside function and we're going to plug it into the derivative of the outside function. That's our f. And then we're going to take that whole thing and we're going to multiply it by the derivative of the inside function, g prime that is. So let's do some sample problems to see how we use the chain rule. Now, what we're going to do for each of these practice problems is simply a method that I offer up to you if you want to do it. You don't have to do it this way. If you feel comfortable using chain rule after doing some certain number of practice problems and you have a way that you like to do it and you know that you get to the right answer, then by all means stick with it. This is just something I offer for when perhaps you're starting out and if you're having just a little bit of trouble trying to get these chain rule problems correct. So the first problem we have here, h of x is equal to the cosine of 3x squared minus 5x plus 2. What I'm going to do is I'm going to take this composition that we have here. I'm going to say that h here is the composition f of g of x. And what I'm going to do is I'm going to clearly label what are f and g of x. I'm going to differentiate each of those guys separately, and then we're going to take the corresponding pieces and plug them into the formula for chain rule. So first let's start with the outside function. The outside function, we see we have the cosine of a whole bunch of stuff. So it looks like we're taking a whole bunch of stuff and plugging it in for where there'd be a variable in the cosine. So that tells me that my outside function, my f of x, is going to be the cosine of x. And then that tells me that all that stuff that I'm shoving into the cosine there, that's going to be my g of x. So 3x squared minus 5x plus 2. And that's all going to be my g of x. Now I'm going to find f prime and g prime separately. The derivative of cosine x, pretty basic, gives us minus the sine of x. And the derivative of g, well, g is just a nice little polynomial here, so really straightforward to find that the derivative is 6x minus 5. So I'm going to take these pieces and I'm going to substitute them into the formula for chain rule. And the formula for chain rule says that h prime is going to be f prime of g of x. So I'm going to take this whole thing right here, and I'm going to have that take the place of the variable that's in f prime. So I'm going to have minus the sine of 3x squared minus 5x plus 2. That's our f prime of g of x part. Now times g prime of x. So times the 6x minus 5. So as you can see, when you break these pieces out separately, when you separately identify what f of x and g of x are, then find f prime and g prime, then you can just nicely substitute pieces in to the formula for chain rule. So that's our first example. We'll go on to the next example here. A little bit of a different look, but nonetheless still a composition. H of x in this case is 6 to the power x minus x to the sixth, and we're taking that entire quantity and we're raising it to the sixth power. So once again, we are going to identify what are the two functions making up my composition. What are f of x and g of x here? So looking at h, it looks like we're taking a whole bunch of stuff and we're raising it to some power. What this should be telling you, I should say, is that taking that verbal cue and translating it into math, all that stuff that we're raising to this power of 6 here, that's going to be my inside function. So that's going to be my g of x. So g of x here is going to be 6 to the power x minus x to the sixth. And then that power that the stuff is being raised to, that is going to be my outside function. So my inside function is taking the place of just x. So my outside function is going to be x to the sixth. Let's find f prime and g prime separately. The derivative of x to the sixth, nice and basic. 6x to the fifth power there. And then finding g prime, again, the derivative of an exponential function with base b is b to the x times the natural log of b. In this case, our b value is 6. So it's going to be 6 to the power x times the natural log of 6 minus, and then we just saw that the derivative of x to the sixth is 6x to the fifth. So we have our f, g, f prime, and g prime. Once again, we're going to take these pieces, we're going to substitute them into the formula for chain rule. So again, this guy, g, being substituted in for the variable in f prime. So this is going to give us 6 times 6 to the x minus x to the sixth, all being raised to the fifth power, times g prime of x. Six to the x times the natural log of 6 minus 6 times x to the fifth. And all that right there is h prime of x. Going on to our next example here. Another h of x here. This is the natural log of the natural log of x minus tan x plus pi to the fifth here. Try to think about this one on your own. Try to identify what are the two functions making up my composition here. What's f of x and what is g of x? Then find f prime and g prime. And then take these pieces and substitute them into the formula for chain rule. So pause the video, try this problem on your own, and then once you think you have it, press play, and we will go through this problem together. Okay, so we're going to identify what are f of x and g of x in this composition that we have here. I look at this and I see that we're taking the natural log of a whole bunch of stuff. So everything that's inside of that bigger natural log there, that's going to be my inside function. That's going to be my g of x here. So g of x is going to be natural log x minus tan x plus pi to the fifth. And then all that stuff is being plugged into natural log x, which is going to be my f of x. The derivative of natural log x is 1 over x. And the derivative of g, well, again, we have the derivative of the natural log of x, which is a 1 over x. The derivative of tan x, as we saw from our videos on product and quotient rule, the derivative of tan x is secant squared x. And now the derivative of pi to the fifth. Do not get caught up on this. Do not think that it is 5 times pi raised to the fourth power. Pi is just a constant, so pi to the fifth is just a constant, and when you differentiate a constant, you get 0. So g prime is just 1 over x minus secant squared x. So now we're going to plug these pieces that we need into the formula for chain rule. I'm taking g of x, and that entire thing is being substituted in for the variable in f prime. So that's going to give me 1 over natural log x minus tan x plus pi to the fifth times g prime. So that right there is your derivative of h. That right there is your h prime of x. Another one here. H of x is e raised to the power cosecant x plus the square root of x minus 4. Again, try to take some time, figure out what are the two functions making up your composition, label those guys as f of x and g of x, then find f prime and g prime, and then take those pieces and substitute them into the formula for chain rule. So once again, pause the video to work on this problem, and then once you think you have it, press play, and we'll go through this problem together. Okay, so let's figure out the two functions, f of x and g of x, that are making up this composition. I'm looking at h here, and I see that we have a whole bunch of stuff in the exponent of e. So thinking about our basic types of functions that we have here, a whole bunch of stuff in the power of e is the visual cue that the inside function is everything that's in that exponent of e. So g of x here is going to be cosecant x minus the square root of x, plus the square root of x minus 4. And then the outside function is e raised to the power of x. And when you take the composition f of g of x, you get exactly h there. Now we need f prime and g prime. The derivative of e to the x, once again, is the nicest thing we can possibly see. It's just e to the x. And the derivative of g, the derivative of cosecant x, this is another guy from our previous video on the product and quotient rules. The derivative of cosecant x is minus cosecant x cotangent x plus the square root of x. The square root of x is x raised to the power 1/2. So using our basic power law, the 1/2 comes down, times the x raised to the power 1/2 minus 1, or minus 1/2. Taking f prime, g, and g prime, and substituting into the formula for chain rule, we're going to get e to the cosecant x the square root of x minus 4, all times g prime of x minus cosecant x cotangent x plus 1/2 times x to the minus 1/2. So this is going to be h prime in this case. The last example that I want to do here looks a little bit odd. We're going to see that we have a function stated in terms of some arbitrary random unknown function, but we can still use a chain rule on this guy, and we still want to. We're going to see this type of thing coming up in our next video. So the next example we have on deck here, h of x is g of x raised to the 8th power plus the secant of g of x. So, looking at h of x here, I see that we have some arbitrary unknown function g of x being raised to some power, plus the secant of this same random arbitrary unknown function. So in both cases, this arbitrary function is being either raised to some power or it's going inside of some trig function. In both cases, this is going to be the inside function. So g of x is just going to literally be g of x. We don't know that it's, say, x squared or x cubed or e to the x. We know that it's just some function g of x. And now the outside function, what are these things taking the place of? Well, they're just taking the places of x's. So f of x here is going to be x to the 8th plus the secant of x. We're going to find f prime. Derivative of x to the 8th is 8 times x to the 7th. And the derivative of secant x, another one of our new trig function derivatives that we learned, it's going to be secant x tan x. And then for g of x just being an arbitrary function, then the derivative of g is just the derivative of g. So g prime of x is just g prime of x. So when we make the substitutions in the proper places in the formula for chain rule, we find that h prime of x is going to be 8 times g of x raised to the 7th power plus secant of g of x times the tangent of g of x. And now I'm taking this entire thing and I'm multiplying it by g prime of x. It's that entire thing. That's all the f prime of g of x piece right there. So this does look like a really odd sample here. This does look like an odd thing that we would come up with, but when we get to our next video, we're going to see why we did the sample. We're going to see why this makes sense. So these are the end of these particular practice problems. I do want to look back at a couple of these problems that we saw here. The second example that we saw, we had some function of x being raised to some power. This is one of the three main special cases you can get when seeing a chain rule problem. The second of the special cases of chain rule you can possibly see is when you're taking the natural log of some long function of x. And the third special case involving chain rule that you could see is your function being e raised to some long thing involving functions of x. So for each of these special cases of the chain rule, there is a special formula out there for them. And we show those in our last slide here. The first one up is the chain rule for logarithms, which says if you're going to take the derivative of the natural log of some function g of x, that's just going to be g prime of x all over g of x. This is the special case of the chain rule where g of x is just whatever g of x is, and f of x is the natural log of x. Second one there is sometimes referred to as the general power law, which says if you have a big function of x being raised to some power and you want to find the derivative of that guy, you're going to take that power down times that big function g of x raised to a power 1 less than the one you had, and it's going to be all that times g prime of x. This is the special case of the chain rule where f of x is x to the n, and your inside function g of x is, again, just some arbitrary function g of x. The third example is chain rule for exponentials. This is when you have e raised to some function of x, and if you want to find the derivative of this guy, it's going to be g prime of x times e raised to the g of x, or, of course, e raised to the g of x, and then times g prime of x on the side of that, both things saying the same thing. This guy here is the special case of the chain rule where our outside function f of x is e to the x, and our inside function g of x is just, once again, our random arbitrary function g of x. So this has been a video on practice problems involving the chain rule. In the next video, we are going to get to some odd-looking equations, things involving x's and y's. And these y's are going to hold a very special property. So we're going to have to use this chain rule here to work with that special property to find the piece of information that we want to find. If you have a question or comment, please be sure to leave it in the comment section below. Otherwise, I will see you later, folks. Take it easy.